Hi, Chris DeLeon here. This is the next video in the series, video 4 in programming using processing for computing as expressive medium, LMC 6310, a course in the digital media program at Georgia Tech. And the videos so far have covered some basics of drawing to the screen, making a ball bounce around off the edges of the screen, and then more recently I took a detour to just review some basic programming structures in terms of conditions, loops, variables, functions, and so on. This time we're going to be focusing on using an array list to have multiple instances of a class simultaneously operating, or the illusion of simultaneity, but it's basically to manage a group of similar objects. So in our previous examples, we showed that every processing application we write is basically going to have at least two functions, two very important functions, setup, which happens the first time that your program runs and only happens once, and in there we typically indicate the size of the screen that we want to use. Let's try a 640, but I think 440 fit. And then draw, which happens repeatedly every time the screen gets updated, about 30 times or so a second. And draw, a rectangle takes 4 arguments, which are the pixels from the left side of the screen, pixels from the top of the screen, width, and the height. And so if we want to draw a little box at the mouse that's 15 by 15 pixels, we can do that. And I'm going to add a background 0 call. This will prevent the screen from leaving a smear. Otherwise, we're going to see consecutive draws. And so kind of got going a little fast at the moment because we're just trying to catch up to where we're at. And so you can see there's my box. And again, for example, if we comment out / ignores the line, a bit of review, I know it's been a few weeks and we're starting from scratch to build back up to this. Now we see it smearing the box everywhere because we're never erasing the screen with that background call. Now we can create variables to keep track of for the computer. And previously we've done things like we had int ball x, ball y. You don't need to necessarily follow along this part if you don't want to, but I think it's going to be useful to demonstrate. X velocity, y velocity. Let's give it a starting point, 50 pixels in, 50 pixels down, going 4 pixels to the right and 2 pixels down per frame. And then every frame, I could move the ball. Remember, plus equals means ball x. This is the same as writing ball x equals ball x plus ball xv. Just going to add the horizontal component to the ball's position in its frame. Going to do the same with y. As always, variable names are in no way significant to the computer. It doesn't know what x and y mean. It doesn't care we've called it ball. These are just labels. These could be pine tree, maple syrup, bananas, and crazy, and the program will still work the same, provided that we put our code in the same places. Now instead of mouse x and mouse y, put ball x and ball y. This is going to make the ball, oops, we don't need to save it. It's going to make the ball appear to move. There it goes. Because each frame, the position that it's being drawn at is being increased by 4 horizontally every frame and by 2 vertically every frame. Remember, we can make that ball appear to bounce by doing bounds checks. So actually, the first thing I'm going to clarify what I was doing right now. I'll comment this out so it doesn't hurt us. My habit is to keep, I'm just going to save it because it'll be good practice. Okay, press play. And now, currently, it just leaves the screen. If we want it to stay on the screen, though, we can check and see if it's in bounds. So if ball x is greater than width, which is an automatic keyword in processing that you can see it turn purple for us, or pink, it's automatically taken on the value of that 640 I set when I configured it. If the ball x is going right, we're going to do this kind of the lazy way. Ball x equals negative ball x. So if it was going positive to the right, then it's going to go negative now. If it goes off the left side of the screen, it's going to flip its speed, because if it was already a negative speed going that direction, it'll go off the edge and reverse its heading. And do the same with y. It's of course a bit faster, but this is really review on what we've done in previous videos. Just want to get caught up to where we're at, height. When I press play, oh, typo, yv, not yx. Press play. Oh, sorry, ball y. I want to check and see if the ball's position is greater than the height of the screen, so off the bottom, not the y velocity. Typos all over the place. That's what I get for trying to rush. Just trying to get us caught up to where we're at so we can move forward, focusing on classes and array lists. But with these new conditions in place, we're checking to see if the ball goes off the screen to reverse its speed. And based on how we're drawing the ball, you'll notice it's being drawn from the top left corner. And so, for example, the bottom of the ball dips off the screen and goes off the sides. But the essential point is we've got a bouncing ball here. And what if we wanted more of them? What if we wanted 2 more, 3 more, 1,000 of them on the screen? We need a better way to do that than simply having to copy and paste that code a million different ways. Because one of the ways we could do it is we could take everything we have here, and I'm just going to show you this as an example of why it's going to be helpful to know how to do what we learn how to do here. I could put underscore B after each of these to mean, okay, this is ball B or ball 2 or whatnot. Start it at a different position, give it a different speed. Okay, so you see I'm changing its speed up, I'm changing its original position. I could then go down here, get all of this code, and first off, I'm going to put this in a function. Draw and move ball, void, draw and move ball. Now remember the way the functions work is that draw and setup are special. They're built into processing. They get called automatically. Setup once when the program starts. Draw every time the screen gets updated, 30 or so times a second. When I come up with my own label like this, I can name it anything, and it'll jump to this part of the code when it gets to that line and then continue after it. So I copied that code for the ball movement. So I now got all that in one place for the first ball. And if I wanted to stick to the way I've been doing the second ball, ball underscore B, I can copy and paste this entire void function, paste it, and basically all I'm trying to show here is like the clumsy way to do this, the way we wouldn't really want to scale, because you can imagine how out of hand this would get if we had more balls. If we wanted to, like I say, have 500 of them. This technically works. This would run, this will happen. I'm going to demonstrate it to you. We have to also change to draw from those coordinates. So now basically we have equivalent code for both of the balls, and sure enough, it works. We have 2 of them. One of those is just using a different set of variables. I followed the same pattern. Now, of course, see the problems with this. There's many of them. One, it's harder to have more of them because there's a linear increase in our code size for each new ball we want to have. We're copying and pasting a lot of code, which is a problem because if we want to fix or change something about it. So, for example, see how the bottom and the side of the ball goes off the right and bottom edge of the screen because it's not accounting for the ball's width. It's just bouncing based on the top left corner of it. If I wanted to fix that for one ball, I'd have to go through and copy and fix all those changes into all the other balls, any one of which I could introduce a typo in and have an error in, and they could all behave differently. What I really want is to be able to centralize all that code into one place to have all the balls behave the same. That's where classes are going to be helpful for us to encapsulate that into its own sort of body. And then furthermore, it's going to be helpful to use an array list to conglomerate a list of those to operate on instead of a single instance of each. Now, I showed in a previous one how we can create new tabs in processing. And the new tab is really just another file. I click on this arrow, new tab, gives me a prompt down here on the bottom of the screen. Let's name it ball. By convention, we use a capital name. And one of the things I showed in the previous video is how we can migrate our ball variables over into the ball file to at least keep that code separate, even before we wrap it into a class, which is what we're about to do. But at first, just to get this code separated out, and by the way, let's go and knock out this ball underscore B business. I'm going to overview the code here in a second to catch up on where I'm at because I'm making changes pretty swiftly. But knock out all the ball underscore B stuff. We don't need that. And so now the neat thing is that this is our entire main body of our code. That's our main. We just have setup, setting the screen size, background, and ball. Over in the ball file, I've got the variables for the ball and the code to draw and move the ball. So we just took that whole function, moved it over here. And again, for now, we've gotten rid of ball B. But this runs exactly like our program did before I added underscore B. Now let's wrap it up into a class. And all I got to do for that, and it actually helps sometimes to move these things over into file first, class ball, and it's got its own braces. So that closing brace corresponds to this open brace for ball. And then I'm going to indent all this. I can actually indent by holding down command and using left and right brackets. It's probably control left and right brackets on Windows. It's a useful thing to be able to indent whole lines, or you can go up to edit and auto format. It's a really helpful, powerful thing in processing that'll fix your sort of spacing indentation, or at least try to, which can help you catch if you're missing a brace anywhere. But so now we have the same code we did before. It's just wrapped in class ball, ball being the name of our new class, and notice it matches the file name. That's a really helpful convention to stick to. Braces at the top, that made braces at the bottom, in addition to, separately from, so this brace here, second to last, is for void draw. You'll see it's boxing that in for me, void draw move ball, showing that that's the corresponding brace. That brace goes to class ball. And now, instead of being able to just call draw and move ball, we have to declare an instance of it. So ball, the ball equals new ball. And now instead of draw and move ball, I say the ball dot draw and move ball. And that dot means run this function, or this method if you prefer the Java terminology, run that function on the instance of ball called the ball. This is going to become more clear what I mean here in just a moment. So there's our ball. And now check it out. So now let's say I want a second ball. Well, let's say we want to do it kind of like we used to do with an underscore b. The ball underscore b dot draw and move ball. Press play. Now first off, it's actually doing it, but you can't really tell because they are overlapping each other completely. So let me change something. So right after setup, let's see we make the ball velocity for one of these balls 3 instead. And let's say we want to change its Y start position to 80. Once again, just like I can use these periods to refer to functions or method calls on that particular ball, I can also use that period to refer to values, variable names, on that particular ball. So on the ball underscore b, I can change the ball y, which is its start value. Remember, I'm doing this in setup, so it's happening right when the program starts. And ball xv to change its horizontal speed. I'm going to press play. Now we have two balls that are no longer overlapping, so we can see that they're separate, each behaving completely independently, each of which is running its own code on its own variables. And more helpfully, if we fix and improve this code, so let's say we want to make it so the edges don't bounce off the ball, or so the edges don't go through the wall, int ball dimension equals, let's say 25 to further exaggerate the effect. Copy that value. I'm going to use that in place of these 15s. Remember that rect by default is drawing from the top corner of it. So instead of bouncing off height, we're going to bounce off height. Well, let's do the math on the other side. Ball y plus ball dimension, so the bottom of the ball goes below the screen, or if the right edge of the ball goes off the right side of the screen. And with those fixes in place, we fix the code in one place, and now it affects both balls. So you'll see that now neither one is going off the edge of the screen. And I keep saying ball, but these are rectangles, these are boxes. So check it out. We'll replace rectangle call with ellipse. There's already going to be a little bug I'm going to show you here in a second. I press play. Now they're definitely balls, with the downside being, so the ellipse draws from the top left corner by default. This is a good reminder that the ellipse draws from the center by default. So ball X and ball Y are now not indicating the middle of the ball, they're indicating the center of it. So we now would have to change our functions. If ball plus half the dimension, you know what's going to help us out here is instead have a value called ball radius, which I'm just going to define as ball dimension divided by 2. So we can get rid of that math once. And then if ball x plus radius is greater than width, if ball x minus ball radius is less than 0, ball y plus radius is greater than height, if ball y minus radius is less than 0. Now I'm checking along each edge. To the right of the ball by radius, above the ball through radius, left ball to radius. And once again, what's nice about this, we fixed it in one place, affected both balls. We could have a third ball, a fourth ball, as many balls as we want here. Let's make these balls even bigger to show the effect. There they go. And we could set any other parameters we want on this. We could have separate colors for each one. For example, we could set them to be different sizes. Although if we did, we'd have to keep radius matched up to dimension. There's ways we'd call that through a function called a setter, which we're not going to get to today. Now, okay, but this is still a little bit clumsy, because if I want to add a third ball, then I start doing this mess, and then I still got to indicate which changes I want to make to it. YV equals 16. I still got to remember to call it down here to make sure I don't miss drawing the ball. Because remember, just because I instantiate it doesn't mean it's going to get drawn. I still have to call a .draw and move ball for it to actually get used. But so now we got 3 balls, one of which I set the vertical speed on 16, so you can see that's our new ball. But it's still kind of clumsy. What we really want is a way we can just have a list of them that we can add new balls onto, and then tell the computer, go over each of these and run that code on it. And here's how we're going to do that. So first off, this has been kind of a clumsy way for us to declare the new balls. A better way to do that is called a constructor. And a constructor, usually when we make a function, we put void before it, but for a constructor, we don't. We just say like ball, and we can take in values for it. Int start x, int start y, int start xv, int running out of space. I was going to break line. start yv, and those are probably sufficient. I mean, we could also set dimension as well. And with that, int start dimension. And so these, like any local value, only exist within the lifetime of this function. This function is going to be called when we instantiate, when we create a new ball. And so we have to keep track of these variables on the ball itself. We no longer need to do that math here, because what's going to happen instead is we're going to be setting the persistent variables on the class based on these values passed in. Okay, I'm running out of time in my reserved room. It's the downside of doing this in the middle of campus. So I apologize for kind of rushing. All x equals, okay. And now when I create new balls, I say new ball equals x, y. We actually don't need to set these anymore at all because these are being set by our constructor. It's actually harmless to leave those there. I'm removing it because we don't want to get confused and think they don't matter. Okay, so now each ball can get an x, y, xv, yv, so like 40, 50, 3, 4, dimension 15. Okay, to find another ball is 100, 100, -2, -3, 10. And another one will say 200, 50, 7, 10, 40. Okay, and now in the process of when those balls get created, they're taking on the separate values that we set for them here in the constructor. But then the one final step is, instead of declaring each of these separately, we're going to say ArrayList ball set equals new ArrayList. Okay. Down here I'm going to say ball set dot add, and then here I'm going to be adding to it the new balls. Adding that new ball. Borrow those parameters we had previously. Adding that new ball. Adding that new ball. So now ball set is going to be an array list, a container, a set, having each of these balls as defined through our constructors. And the beauty of this is that now, instead of having to manually call these draw and move operations on each, I can make a for loop that iterates through the ball set for int I equals 0, I is less than ball set, leave dot length. But we're going to find out in a second. Might be size. Size, it almost certainly is. Size with parentheses. Okay, and now I have to get a temporary handle on it. Ball equals one ball equals casting it as a ball, ball set dot get I. I know there's an awkward construction. I'll be able to explain it here in a second. All right, and there they go. And so what's happening there is we have an array list which can have an arbitrary number of instances added from classes. We're creating 3 new instances of this ball class that we're defining through the constructor, so that each have different settings to them when we do these adds. And then in draw, each frame, it's going through the full list of balls, and it is getting a handle on the ball, so the array list we're declaring here, we're not indicating the type, we're not telling it to expect a ball. So we have to then tell it when we get it back from it, okay, we know it's a ball. We know we can call ball-like functions on it. We know we can reference ball-like variables on it. This one ball is indicating that we have a local value of type ball. We're labeling it one ball, which we call one ball dot draw and move ball. So in order that one ball takes on the properties or reference to the 0th ball, the 1st ball, and the 2nd ball. And if we wanted to have a little more fun, we could say I is less than 100, I plus plus. We can come up with some parameters for these. So start position, random, I don't know, 100 plus 200, right? And then for the y value, got a big enough window, we'll do the same. Okay, random horizontal speed, random 5 minus, yeah, what the heck, we'll just stick to them, I'll go in the same direction. Negative random 5, let's give them some minimum speed of like 1, minus 2, and then ball size, we'll say 5 plus random 25. And so now I've randomized each of those parameters for the program start. It's going to create 100 different balls when I press play. Oh, it's wanting floats. I'd have to cast it as integers. Random returns a float value, and casting it as an integer will tell the computer to treat it like an integer. I think that's what we need. Yep, there we go. And there's 100 balls. right? With the same code we already had that worked for 3, and I didn't have to specify them because I'm using random parameters. Let's try 1,000 balls. And you can see why, okay, well, we're getting a bit of a performance degradation, but this is clearly such an easier thing to handle and to deal with than if we had tried to just do that thing that we started with underscore B, underscore C, underscore D, and so on. Array lists are an incredibly powerful concept, and by using them in combination with our construction of classes like ball, we can have 100 enemies on the screen, we can have 100 shots, 100 pellets, 100 paintbrush strokes, each of which we can all program in one place in the code to make changes or fixes to its behavior to make it more advanced. So let's say we have all these balls, right? Let's say we have 500 balls, and I suddenly want to add a notion of gravity to it. Well, gravity is easy. We just had a constant value every time to its y velocity. Let's change these to floats so that they can be a little smoother. I'm changing the x velocity and y velocity to floats. We can have partial values or fractions and decimals. I'm going to keep that at any moment now, so wish me luck. And so I'm going to add a small incremental continuous value every single frame to the y velocity, which should act as gravity. And there we go. We now have 500 bouncy balls instead. You can see there's some stuck at the top of the screen. There's some little bugginess going on. We get fewer balls, and you'll see a better effect of what I'm talking about. 20 balls. And we now have bouncy balls because we added gravity to 1. Okay, that's all the time I have. Thanks so much. I'll talk to you again soon. Bye-bye.